Conductors rated for 90 degrees Celsius have higher ampacity ratings compared to those rated for 75 degrees Celsius. This means they can carry more current without overheating. The higher ampacity of 90 degrees Celsius rated conductors reduces the need for larger conductor sizes, which can lead to lower voltage drop and energy savings. 90 degrees Celsius rated conductors are designed to withstand higher temperatures, prolonging their lifespan and reducing the risk of premature failure. While 75 degrees Celsius wire table amp ratings ensure the safe installation of conductors, 90 degrees Celsius rated conductors and connectors are also tested and certified to meet safety standards. They undergo rigorous testing to ensure they can operate safely at higher temperatures. When considering using 90 degrees Celsius rated conductors and connectors, the following factors should be taken into account. Firstly, National Electrical Code, or NEC, compliance. Secondly, connector compatibility, and thirdly, overcurrent protection. The NEC requires the use of conductors and connectors rated for the specific temperature conditions of the installation. If the NEC specifies 75 degrees Celsius ratings, 90 degrees Celsius rated conductors and connectors may not be permitted without special approval. Ensure that the panel or disconnect connectors are rated for both the 90 degrees Celsius temperature rating and the type of conductor being used. Overcurrent protective devices must be properly sized for the ampacity of the 90 degrees Celsius rated conductors. It's important to recognize the benefits that 90 degrees Celsius rated conductors and connectors can offer. One of the primary advantages is increased ampacity. Conductors rated for 90 degrees Celsius can handle more current than their 75 degrees Celsius counterparts, allowing for potentially smaller conductor sizes for the same load. This can translate to cost savings and easier installation, especially in high current applications. Another significant benefit is energy savings. The higher ampacity of 90 degrees Celsius conductors can lead to lower voltage drop along the conductor length. This reduced voltage drop means less energy is lost as heat, resulting in a more efficient electrical system and lower operating costs over time. Moreover, 90 degrees Celsius rated conductors are designed to withstand higher temperatures, contributing to improved conductor longevity. This enhanced heat resistance reduces the risk of premature failure, extending the lifespan of the electrical system and minimizing maintenance requirements. While the NEC 75 degrees Celsius wire table amp ratings provide a safe and conservative approach to conductor sizing, 90 degrees Celsius rated conductors and connectors are also thoroughly tested and certified to meet stringent safety standards. These components undergo rigorous evaluations to ensure they can operate safely at high temperatures without posing a risk of fire or electrical hazards. However, there are specific considerations that must be carefully addressed when contemplating the use of 90 degrees Celsius rated conductors and connectors. One of the most critical factors is NEC compliance. The NEC mandates that conductors and connectors be rated for the specific temperature conditions of the installation. If the NEC explicitly specifies 75 degrees Celsius ratings for a particular application, using 90 degrees Celsius rated conductors and connectors may not be permitted without obtaining special approval from the authority having jurisdiction. Another essential consideration is connector compatibility. It is imperative to ensure that the panel or disconnect connectors used in conjunction with 90 degrees Celsius rated conductors are also rated for both the 90 degrees Celsius temperature and the specific type of conductor being used. Mismatched connectors can lead to overheating, insulation damage, and potential electrical failures. Overcurrent protection is also paramount. Overcurrent protective devices, such as circuit breakers and fuses, must be properly sized to match the ampacity of the 90 degrees Celsius rated conductors. Using incorrectly sized overcurrent protection can result in nuisance tripping, equipment damage, or even fire hazards. When making decisions about conductor and connector selection, it's important to understand the temperature ratings involved. Electrical conductors and connectors are assigned temperature ratings that indicate the maximum operating temperature they can withstand without degrading their performance or posing a safety risk. These temperature ratings are typically expressed in degrees Celsius. The 75 degrees Celsius rating and the 90 degrees Celsius rating are common examples, but other temperature ratings may also be encountered. The temperature rating of a conductor or connector is determined through rigorous testing and certification processes, ensuring that the component can safely operate at or below its specified temperature. Exceeding the temperature rating of a conductor or connector can lead to various problems, including insulation degradation, reduced ampacity, increased resistance, and premature failure. In extreme cases, overheating can also pose a fire hazard. The NEC provides guidelines and requirements for conductor and connector temperature ratings based on the specific application and installation conditions. These guidelines help ensure that electrical systems are designed and installed in a safe and reliable manner. The NEC wire tables, such as those found in NEC Table 310.15, B16, provide ampacity values for conductors based on their temperature rating and other factors. These tables are essential tools for selecting the appropriate conductor size for a given load. When selecting conductors and connectors, it's crucial to consider the ambient temperature of the installation environment. Higher ambient temperatures can reduce the ampacity of conductors and may necessitate the use of higher temperature rated components. The rating factors, as outlined in the NEC, must be applied to account for ambient temperature and other conditions that can affect conductor ampacity. Always consult the NEC and other relevant standards for specific requirements related to conductor and connector temperature ratings. A qualified electrician can provide valuable guidance in selecting the appropriate components for a given application. In addition to temperature ratings, it's also important to consider other factors when selecting conductors and connectors, such as voltage rating, insulation type, conductor material, and environmental conditions. Choosing the right components is essential for ensuring the safety, reliability, and longevity of electrical systems. When working with electrical systems, always prioritize safety and follow all applicable codes and regulations. Electrical work should only be performed by qualified individuals who have the necessary training and experience. Always disconnect power before working on electrical equipment and use appropriate personal protective equipment. Understanding the principles of conductor and connector temperature ratings is essential for designing and installing safe and efficient electrical systems. By selecting the appropriate components and following all applicable codes and regulations, you can help ensure the reliability and longevity of your electrical infrastructure. While the NEC 75 degrees Celsius wire table amp ratings provide a safe and conservative approach to conductor sizing, the use of 90 degrees Celsius rated conductors and connectors may offer benefits in terms of increased ampacity, energy savings, and conductor longevity. It is important to consult with a qualified electrician and carefully consider the specific requirements of the installation when making this decision. The key difference between 75 degrees Celsius and 90 degrees Celsius wire involves the maximum operating temperature each type of wire can safely handle. This difference in temperature rating has implications for the wire's ampacity, which is the amount of electrical current it can carry without overheating. 75 degrees Celsius wire is designed to operate safely at temperatures up to 75 degrees Celsius or 167 degrees Fahrenheit. 90 degrees Celsius wire, on the other hand, is designed to operate safely at temperatures up to 90 degrees Celsius or 194 degrees Fahrenheit. Because 90 degrees Celsius wire can withstand higher temperatures, it generally has a higher ampacity than 75 degrees Celsius wire of the same size. This means that 90 degrees Celsius wire can carry more electrical current without overheating. The specific ampacity of a wire depends on several factors, including the wire's size, insulation type, and installation conditions. The National Electrical Code, or NEC, provides tables that list the ampacities of different types of wires under various conditions. These tables are used by electricians and electrical engineers to select the appropriate wire size for a given application. While 90 degrees Celsius wire can offer advantages in terms of ampacity, it's important to consider the specific requirements of the application and any limitations imposed by the NEC or other codes and standards. In some cases, the use of 90 degrees Celsius wire may not be permitted or may require special considerations, such as the use of appropriately rated connectors and equipment. Here are some key considerations when choosing between 75 degrees Celsius and 90 degrees Celsius wire. Firstly, ampacity requirements. Secondly, temperature rating of equipment and terminals. And thirdly, code requirements. Determine the amount of electrical current that the wire needs to carry. If the current is relatively high, 90 degrees Celsius wire may be a better choice due to its higher ampacity. Check the temperature rating of the equipment and terminals to which the wire will be connected. The wire's temperature rating must be equal to or greater than the temperature rating of the equipment and terminals. Consult the National Electrical Code, or NEC, and any other applicable codes and standards to ensure that the wire selection complies with all requirements. When installing electrical wiring, it's important to follow all applicable codes and standards and to use appropriately rated equipment and materials. Improper installation can lead to overheating, electrical shock, or fire. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns about electrical wiring. In summary, 75 degrees Celsius and 90 degrees Celsius wire differ in their maximum operating temperatures and ampacities. 90 degrees Celsius wire can offer advantages in terms of ampacity, but it's important to consider the specific requirements of the application and any limitations imposed by codes and standards. Always follow safe electrical practices and consult with a qualified professional if needed. In addition to the considerations mentioned earlier, there are a few other factors to keep in mind when selecting between 75 degrees Celsius and 90 degrees Celsius wire. Firstly, insulation type. Secondly, cost. And thirdly, availability. The insulation type of the wire can affect its ampacity and temperature rating. Some insulation types are better suited for high temperature applications than others. Consider the cost of the wire. 90 degrees Celsius wire is typically more expensive than 75 degrees Celsius wire. Check the availability of the wire. 90 degrees Celsius wire may not be readily available in all areas. The choice between 75 degrees Celsius and 90 degrees Celsius wire depends on the specific requirements of the application and a variety of factors, including ampacity, temperature rating, equipment compatibility, code compliance, insulation type, cost, and availability. It's important to carefully consider all of these factors before making a decision. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns about electrical wiring. They can help you select the appropriate wire for your application and ensure that it is installed safely and correctly. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations in the United States. It provides comprehensive guidelines for electrical wiring, equipment, and systems. Understanding the NEC is essential for anyone involved in electrical work, including electricians, electrical engineers, contractors, and inspectors. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The NEC is organized into chapters, articles, and sections, covering a wide range of topics related to electrical installations. Some of the key areas covered by the NEC include: firstly, wiring methods; secondly, equipment and appliances; and thirdly, special occupancies. The NEC specifies the types of wiring methods that are permitted for different applications. This includes information on conduit, cables, and other wiring systems. The NEC provides requirements for the installation and use of various types of electrical equipment and appliances, such as lighting fixtures, motors, and transformers. The NEC addresses the unique electrical requirements of special occupancies, such as healthcare facilities, hazardous locations, and swimming pools. The NEC is not a static document. It is constantly evolving to keep pace with changes in technology and safety practices. The NEC is developed through a consensus-based process that involves input from a wide range of stakeholders, including electrical professionals, manufacturers, and consumers. The NEC is adopted by state and local jurisdictions, which may make modifications to the code to suit their specific needs. It is important to be aware of the specific electrical codes that are in effect in your area. The NEC is a complex and comprehensive document, and it is essential to have a thorough understanding of its requirements before undertaking any electrical work. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and other sources. Many online resources and training programs are also available to help you learn more about the NEC. In addition to the NEC, there are other codes and standards that may apply to electrical installations depending on the location and type of project. These may include state and local building codes, as well as industry standards developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and Underwriters Laboratories, or UL. It's important to be aware of all applicable codes and standards and to ensure that your electrical work complies with all requirements. Working with electricity can be dangerous, and it's essential to follow safe work practices at all times. Always disconnect power before working on electrical equipment and use appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to perform electrical work, it's best to hire a licensed electrician to do the job. The National Electrical Code, or NEC, is a vital resource for ensuring safe electrical installations. By understanding the NEC and following its requirements, you can help protect yourself, your property, and others from electrical hazards. The NEC provides specific requirements for the installation of electrical conductors in different types of raceways, such as conduit and tubing. These requirements are designed to ensure that conductors are properly protected from physical damage and environmental conditions, and that they are installed in a safe and reliable manner. The NEC specifies the types of raceways that are permitted for different applications, and it provides guidelines for selecting the appropriate size and type of raceway for a given number of conductors. The NEC also specifies the maximum number of conductors that are permitted in a raceway, based on the size of the raceway and the type of conductors being installed. These limitations are designed to prevent overheating and to ensure the conductors can be easily pulled into and out of the raceway. When installing conductors in raceways, it's important to follow all applicable NEC requirements and to use appropriate tools and techniques. This includes properly lubricating the conductors to reduce friction and using pulling equipment that is designed to avoid damaging the conductors or the raceway. The NEC also provides requirements for the support and securement of raceways. Raceways must be properly supported to prevent them from sagging or becoming damaged, and they must be securely fastened to walls, ceilings, or other structures. In addition to the NEC, there may be other codes and standards that apply to the installation of conductors in raceways depending on the location and type of project. These may include state and local building codes, as well as industry standards developed by organizations such as the Insulated Cable Engineers Association, or ISA. It's important to be aware of all applicable codes and standards and to ensure that your electrical work complies with all requirements. Working with electricity can be dangerous, and it's essential to follow safe work practices at all times. Always disconnect power before working on electrical equipment and use appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to perform electrical work, it's best to hire a licensed electrician to do the job. The NEC is a valuable resource for ensuring safe and reliable electrical installations. By understanding the NEC requirements for the installation of conductors in raceways, you can help protect yourself, your property, and others from electrical hazards. The electrical connectors are used to join two or more conductors together, providing a secure and reliable electrical connection. There are many different types of electrical connectors available, each designed for specific applications and conductor types. Some common types of electrical connectors include firstly, wire connectors, secondly, crimp connectors, and thirdly, terminal blocks. These are used to join two or more wires together. They typically consist of a plastic body with a metal inset that is used to grip the wires. These are used to create a permanent connection between a conductor and a terminal. They are typically made of metal and are crimped onto the conductor using a special tool. These are used to connect multiple conductors to a single point. They typically consist of a series of terminals that are mounted on a block of insulating material. When selecting electrical connectors, it's important to consider several factors, including the type of conductors being joined, the size of the conductors, the voltage and current rating of the connection, and the environmental conditions. The NEC provides specific requirements for the selection and installation of electrical connectors. These requirements are designed to ensure that connectors are properly sized and installed, and that they provide a safe and reliable electrical connection. The NEC also specifies the types of connectors that are permitted for different applications. When installing electrical connectors, it's important to follow all applicable NEC requirements and to use appropriate tools and techniques. This includes properly stripping the insulation from the conductors and using the correct crimping tool for crimp connectors. The NEC also provides requirements for the marking and identification of electrical connectors. Connectors must be clearly marked to indicate their voltage and current rating, as well as the type of conductors they are designed to be used with. In addition to the NEC, there may be other codes and standards that apply to the installation of electrical connectors, depending on the location and type of project. These may include state and local building codes, as well as industry standards developed by organizations such as Underwriters Laboratories or ALL. It's important to be aware of all applicable codes and standards and to ensure that your electrical work complies with all requirements. Working with electricity can be dangerous, and it's essential to follow safe work practices at all times. Always disconnect power before working on electrical equipment, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not qualified to perform electrical work, it's best to hire a licensed electrician to do the job. Electrical connectors are essential components of electrical systems. By selecting and installing connectors properly, you can help ensure a safe and reliable electrical connection. Overcurrent protection is a critical safety feature in electrical systems, designed to protect against excessive current flow that can cause overheating, damage to equipment, and even fire. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. The NEC provides detailed requirements for overcurrent protection, including the selection, installation, and coordination of overcurrent protection devices. These requirements are designed to ensure that electrical systems are adequately protected from overcurrent conditions. Circuit breakers are electromechanical devices that automatically interrupt the flow of current when an overcurrent condition is detected. They can be reset after the overcurrent condition has been corrected. Fuses are single-use devices that interrupt the flow of current when an overcurrent condition is detected. They must be replaced after they have been blown. The NEC specifies the types of overcurrent protection devices that are permitted for different applications, and it provides guidelines for selecting the appropriate size and type of device for a given circuit. The NEC also provides requirements for the location and installation of overcurrent protection devices. Overcurrent protection devices must be readily accessible and must be installed in a manner that protects them from physical damage and environmental conditions. In addition to the NEC, there may be other codes and standards that apply to overcurrent protection depending on the location and type of project. These may include state and local building codes, as well as industry standards developed by organizations such as Underwriters Laboratories or ALL. It's important to be aware of all applicable codes and standards and to ensure that your electrical work complies with all requirements. Working with electricity can be dangerous, and it's essential to follow safe work practices at all times. Always disconnect power before working on electrical equipment, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not qualified to perform electrical work, it's best to hire a licensed electrician to do the job. Overcurrent protection is a vital safety feature in electrical systems. By understanding the principles of overcurrent protection and following the NEC requirements, you can help protect yourself, your property, and others from electrical hazards. The electrical panels and disconnects are essential components of electrical systems, providing a central point for distributing electricity and for safely disconnecting power to circuits and equipment. Electrical panels, also known as load centers or breaker panels, are metal enclosures that house circuit breakers or fuses. These devices protect individual circuits from overcurrent conditions such as short circuits and overloads. Disconnects or switches are other devices that are used to isolate electrical circuits or equipment from the power supply. They are used for safety purposes, such as during maintenance or repairs. The NEC provides detailed requirements for the installation and use of electrical panels and disconnects. These requirements are designed to ensure that electrical systems are installed safely and reliably. The NEC specifies the types of electrical panels and disconnects that are permitted for different applications, and it provides guidelines for selecting the appropriate size and type of equipment for a given installation. The NEC also provides requirements for the location and installation of electrical panels and disconnects. They must be readily accessible and must be installed in a manner that protects them from physical damage and environmental conditions. In addition to the NEC, there may be other codes and standards that apply to electrical panels and disconnects depending on the location and type of project. These may include state and local built-in codes, as well as industry standards developed by organizations such as Underwriters Laboratories or ALL. It's important to be aware of all applicable codes and standards and to ensure that your electrical work complies with all requirements. Working with electricity can be dangerous, and it's essential to follow safe work practices at all times. Always disconnect power before working on electrical equipment, and use appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to perform electrical work, it's best to hire a licensed electrician to do the job. Electrical panels and disconnects are critical components of electrical systems. By understanding the requirements for their installation and use, you can help ensure a safe and reliable electrical system.